Alan Turing was an English mathematician, wartime codebreaker and pioneer of computer science. He studied mathematics at Cambridge University and subsequently taught there, working in the burgeoning world of quantum mechanics. It was at Cambridge that he developed the proof which states that automatic computation cannot solve all mathematical problems. This concept, also known as the Turing machine, is considered the basis for the modern theory of computation. In 1938, he began to work secretly for the Government Code and Cipher School. At the outbreak of war, he took up a full-time position at Bletchley Park. Here, he played a vital role in deciphering the messages encrypted by the German Enigma machine, which provided vital intelligence for the Allies. He took the lead in a team that designed a machine known as a bomb that successfully decoded German messages. After the war, Turing began to develop a machine that would logically process information. He worked first for the National Physics Laboratory, where his plans were dismissed by his colleagues, and the lab lost out on being the first to design a digital computer. In 1949, he went to Manchester University, where he directed the Computing Laboratory and developed a body of work that helped to form the basis for the field of artificial intelligence. Turing was prosecuted in 1952 for homosexual acts and accepted chemical castration treatment. He committed suicide in 1954. In 2009, British Prime Minister Gordon Brown made an official public apology on behalf of the British government for the appalling way he was treated. Queen Elizabeth II granted him a posthumous pardon in 2013. Our Insight speaker for this evening is Dr. Larissa Suzuki. Dr. Suzuki is an award-winning, passionate computer scientist, entrepreneur and inventor. In her professional career, she has spent more than 11 years advancing many fields of computer science and engineering, including smart cities, data infrastructures, machine learning, emerging technology, and computing applied to medicine and operations research. At the age of 21, she founded a software studio startup, and throughout her career she has received numerous awards, scholarships and recognitions from MIT, Intel, Google, IBM, ACM, Microsoft Research and Siemens, to name just a few. In 2017, she was the Women's Engineering Society Prize winner for the Young Woman Engineer of the Year Awards. Ladies and gentlemen, please put your hands together for your Insight speaker tonight, Dr. Larissa Suzuki.
Hi. Hi, everyone. Thank you very much for having me here. It's such a pleasure to be here today talking to you. So I'm going to talk to you a little bit about smart cities and the power of applied computing helping us to solve global problems that we have today. 270 billion, that is the cost of energy waste in the built environment. So buildings, they are responsible for 80% of all energy consumption globally. And we're going to have a lot of people moving into urban areas, and we have to create accommodation to support that people. So with the urban population increasing in cities, we're going to have to build every single day 2,000 apartment buildings, each one with capacity for 90 people, and most of them will have to be affordable, as most people coming to live in cities, they're going to leave rural areas to come to urban environments. 173 billion worth of food is thrown away every single year. We waste 500 trillion water in the food we are going to throw away. And yet 1 in 4 cities around the globe, they're experiencing water scarcity, or they're going to be experiencing this in the next 15 years. London is one of those cities that are going to experience that difficulty in the next 10 years. And while we throw away all that food, 1 in 90 people around the globe, they are undernourished. And every 15 seconds, a child dies because they have nothing to eat. 100 billion pounds, that is the cost of congestion. We have on the roads as of today 1 billion cars, and that number is going to double in the next 10 years. And we humans, we spend 4 to 6 months of our lives trying to find a parking space. That's really a waste of time because we humans, we are so expensive, right? And 96% of the time, those cars, they're not used. They are left parked somewhere, and when they are going around, they're not filled to its full capacity. So 81% of the time, they're just like they just have one driver. 100 billion pounds, that's the cost of air pollution. We have around 6 billion people globally being exposed to very dangerous levels of pollution, and 3 million deaths every single year is associated with air pollution. And air pollution is not only bad for our lungs and respiratory system, that is also very bad for our cognitive ability. So a research done in Israel in 2014 demonstrated that kids, when they were exposed to air pollution at their school, they performed very badly on tests, and that negatively impacted their ability to get into universities. So we have cognitive impairment as a result of air pollution too. And most of the time that air pollution comes from inefficiency in our urban environment. 270 billion, that's the cost of waste. We humans, we consume 1 million plastic bottles every single minute. Less than half of that gets recycled, and only 7% become new bottle. And that plastic ends up in the ocean, in the landfill, or inside of our stomach. Because if you rely on seafood, you eat in average 11,000 tiny pieces of plastic every year. 70% of the world's population, they don't have access to safe surgical care. And we're going to have a shortage of 2.3 million doctors around the globe, not only doctors to conduct general operations, but to conduct specialized operations in kids and adults. And 70% of the world's population, that is about like around 6 billion people, they're going to be living in urban areas. So these are the largest cities that we are going to have by 2050. And we know that the majority of people will be living inside of that circle. So when I started my research on smart cities 7 years ago, I asked myself, how does success look like for our humanity, for our societies? And when I started doing my research, I realized that we have to look into 4 different aspects. The first one is the infrastructure of cities. They have evolved through many vintages of technology, most of the time very fragmented. So we have energy over here, water over there, and transport over here, but they are so reliant upon one another. And then they have to be very interconnected so they can adapt to its environment, make change as population increase to meet supply with demand. And also, we rely a lot on finite resources, and we have to start very soon rely much less on that and start using assets to its full potential. So data, disruptive technology, and social innovation helps us to collect information about the urban environment, how the urban environment is operating, what are the needs of our citizens, and start to embed knowledge into the urban environment and start changing the way that we learned how to live. One of the things that is helping us to interconnect those systems is the Internet of Things. So it's predicted that by 2050, we're going to have 50 billion connected devices. Those are sensors, mobile phones, and wearables. And we have a lot of stuff that kind of served as driver for that increase in connected devices. The first one is that the computer power would double every 2 years and for the same cost. That is kind of the Moore's law. And then we also have the power of the network effects, that the more nodes you have in a network, the more value you have. And also the development advancements on big data technologies and cloud computing, so computer cycles on demand, pay as you go, that also helped us to process more information, and also advancements on data analytics and also machine learning. And by data analytics, I also mean data visualization, that we have exciting new ways to visualize data from outside of the databases. So we can instrument cities, we can instrument bridges, but we can also repurpose assets. So in the past, this would serve only as a lamppost, but with the Internet of Things, we can make this as, as a device that could check for parking space, we could track air pollution, flood levels, and we could reutilize this asset for multiple purposes. And the beautiful idea behind this is that all that information can be collected and shared across an infrastructure that is technology agnostic, is secure, and will give access to information to many applications and systems and stakeholders. A good example that we have, this bin over here is from the project called Big Belly. So the idea is not only track whether a bin is full of trash and ready for collection, but also helps us to track how much our society is recycling. So particular people could go into the app and see the map and see, oh, I'm not recycling as much as I should. So it also helps like changing behavior of humans so they can recycle more and help us to support a more circular economy. Another exciting project is the strawberry tree, which is the one over there. And that is a solar, it's a tree that is electronic, that collects solar power, and that gives to users free of charge, besides information about the environment where they are running, they can charge their phones. It really supports the community in getting together. Other projects include the Oxford Flood Networks. So the idea is to give homeowners a sensor that can be put inside of their houses and outside alongside the Oxford Canal. So if there's any risk of flood, all the residents would know about this. And then the users, they become responsible for the sensors. They also become part of the data processing. And again, we have many technologies today, like embedding sensors on the ground to identify whether a parking space is available for people to go and park their car and stop looking around for 4 months. So as our ability to collect data increased, also our ability to process and see data also increased. As of 2011, machine learning algorithms in classification tasks, they had 20% of error. So this is what we could really see at that time. As we started having more computer power, we could run more sophisticated algorithms, and now the error level decreased to 2%. And in humans, we get 5% of error when we do classification tasks. So machines, they're doing much better than now us today. So we can see this as the development in biology. It was so difficult for us to use the microscope and see the nucleus inside of a leaf many, many years ago. And today we can go really to the DNA level. So we can see at the same advancement as we have in biology. A good application of this is a self-driving car, driverless car, which the video is not playing. Yes, there we go. Okay, so the idea of autonomous vehicles is to enable cars to drive around the city, being aware of the environment, collect information, distinguishing whether that is a person or a lamppost. That is very serious. We have to be able to understand this. And deep learning, which we can understand as the modern reincarnation of the neural networks of the 60s, they are here today to help us to collect data and process data very fast on demand. And this is enabling us to develop solutions that will help a lot of people around the globe. So we have millions of people with visual impairment and people depending on a wheelchair. And most of the times they are left at home, they cannot take part in society. The right to the city is not enabled. And these types of technology can help them to regain their right to the city. The only problem that we have today is we are investing a lot of money in cars, creating amazing fast cars. However, we are not investing as much on traffic management system. And the cars have got to talk to the road and talk back. It has to be a two-way communication. So we have to improve research in that area. Another type of very amazing technology that we are using in smart cities today is augmented reality. So in this image, we see a doctor in Bolivia. He's performing an operation in a little boy, but he does not know how to do that operation. He's not specialized on that field. So in that monitor there, you see there's a doctor across the globe with a camera, and then he can really see the image of that boy, because this doctor is using a very simple technology. It's just a tablet filming the face of the boy. So this doctor across the globe is really teaching this doctor here, oh, you make the incision over here. This is where you do the stitches. So we are really training people across the globe. And this is so exciting because the power of computing and developments in 5G is enabling us to do this. We are calling this the Internet of Skills. And if you're interested in this work, I strongly recommend you to check the work of Professor Misha Dowler from King's College London. He's pioneering this work, and it's really an exciting area. Another piece of work that we are doing is also exploring the wisdom of the crowds that is about social innovation. I'm not sure how much of you are familiar with OpenStreetMaps, but it's just like Google Maps, but open source. And most of the time that gets updated much quicker than Google Maps. And we have users like you and me editing the maps to help people to have access to amazing maps that will power wonderful applications to help mobility in the city. And this is a map shows the number of edits per square kilometer. So we see United States, Europe, and Japan. They're very active in helping us to get amazing maps. So this is an example of a forum, a discussion in a forum from OpenStreetMaps. In here, on the very right hand, we see it looks like a, a normal flat street, right? But you as a human, when you go there, you see actually it's a stair. So how can you provide that route to somebody in a wheelchair? So that's why it's so important for us to use humans to also be part of the data processing and helping us to do what machines cannot do as of today. Another interesting project is called Blindways, and that is a project done in Boston. So basically, blind people, they struggle a lot to find the bus stop. They miss it because GPS is not very good for micro-navigation. So you have like 30 feet kind of fuzzy, blurry area that we're not sure whether you should go over here or over there. So what they did was they recruited volunteer citizens as you and me to get their phones, go around the street and record. Okay, you keep going. Oh yeah, this is the bus stop. So what they did was they provided that app to blind people. They would wear their earphones and they would go around with that app until they found the bus stop. That helped them very much with micro-navigation. And the power of people helping us to create a smarter planet is just like amazing and is really, really valuable for us. As our ability to collect data, to process data has increased a lot, the data complexity has also become like, it's really, really difficult for us to understand and comprehend all the data available on the web. Google is trying to do this for many years, and we still have a lot of challenges to go through. We have data coming from different like sampling and velocity. And when I talk about the Internet of Things, I'm not talking about sensors, the 10-cent sensor that you buy. I'm talking about professional sensors, because you cannot rely on data that is bad sampled, especially to actuate in the urban environment. So we have a lot of complexity in dealing with data, with semantics. Is this data here connected to that one over there? So we can merge this data and integrate. But a very crucial part is the data veracity. And I'm not only talking about like how good the data is, but it's about like, is there any bias in your data? Is your data biased towards something? Because think about it, we implement a security system that is totally autonomous. If my data is biased, or there's bias or anything that is not ethical, how can I trust that system to act? And we always have to remember that if you run machine learning, deep learning, or MapReduce in any kind of bad data, the only output you're going to have is this one. You cannot jiu-jitsu your way out of bad data. So in the end of the day, smart cities is all about let's collect data, integrate our system, and share this across different stakeholders to ensure that we have a more just society for everyone, because smart cities cannot be a commodity that will only serve a small proportion of the population. It has to be for all. And I would tell you like 5 key things that I think smart city systems should have. The first one is to be ethical by design. That is crucial because we're talking about creating systems for humans. Secure and trustworthy, and also be distributed, to not have a single point of failure, and be exciting and democratic as the internet, and privacy preserving, and not focus on solutions for first world's problem only. Because we think about like, let's only solve problems of first world, like put drones around. But in fact, London itself is going to experience a lot of infrastructure problems that the third world are experiencing today. So we have to focus on a diverse range of solutions. And the final one is to be inclusive and transparent, because in the end of the day, every single piece of technology can be used to either include or to exclude, and the right to the city is a right for everybody. Thank you very much. Now the fun is going to begin. I'm going to introduce you to the main speaker of today. So Dr. Andy Harter, he's a distinguished innovator and entrepreneur. He was Director of Research and Engineering at the influential AT&T Cambridge Laboratory, where he led many hardware and software projects through commercial to exploitation. He was responsible for VNC software and its seminal role in establishing the remote access market. The technology is on over 1 billion devices and is on more different kinds of computer than any other application, and is an official part of the internet today. Andy has an MA and a PhD from Cambridge University, where he's a fellow of the Computer Laboratory and is a chair of the Cambridge Network. He has received numerous awards, including the Silver Medal and Mac Robert Award from the Royal Academy of Engineering and the Faraday Medal from the IET. In 2017, he was awarded CBE for his services to engineering. Ladies and gentlemen, please help me to welcome to stage Dr. Andy Harter.
Thank you, Larissa, very much indeed for that very warm introduction. I'm delighted to be here this evening, and it's a huge honour to give the 2018 Turing Lecture. I'm going to begin with something very non-scientific. Do you think innovation and technology owe more to science or to art? Hands up if you think science. Okay. Hands up if you think art. Well, not very conclusive, about 50-50, I would say, pretty evenly split. Okay, now our arms are warmed up, let's try some more audience participation. We're looking for the connection, a little bit like Victoria Corran's TV game show Only Connect. When you think you know the connection, put your hand up and keep it up. So what links this with this? Anyone know? Hands up? No. Another clue. What links this with this? Anyone know? No one? Okay, one last clue. What links this with this? Anyone? No one at all. Da Vinci, I heard someone say. Absolutely. It's Leonardo da Vinci, one of the greatest and most influential minds of all times and a true polymath. He was the leader of the Italian Renaissance, not only painting masterpieces, but also exploring the intricacies of human anatomy and designing machines and inventions and conceptualizing future technologies. However, Da Vinci was first presented at the Milanese court as a musician. He had a formidable and prodigious talent with the stringed instruments of any kind, in particular the lira da braccio, a forerunner of the violin. But amongst his thousands of sketches is this self-propelling vehicle from about 1480. The cart was powered by large coiled springs that would have propelled it about 100 metres. It had an ingenious control mechanism that would have taken it on a predetermined course. Full-size working model has been made recently and has proved the genius of ideas. Now, it's electric, not clockwork, but otherwise this is a modern self-propelling vehicle which is capable of steering itself. Da Vinci is less well known as a sculptor, but Gran Cavallo, or Leonardo's horse, was commissioned by the Duke of Milan and intended to be the largest equestrian statue in the world. Da Vinci did extensive preparatory work for this and even made some clay models, but the work only came to life in more recent times. But another set of his sketches show his talents as an architect, engineer, and inventor to describe in detail the design of an entire city. Motivated by the effects of a great plague which devastated Milan, Da Vinci completed detailed plans for an ideal city to house thousands, complete with sanitation, an integrated transport system, and convective ventilation. His lifelong fascination and insight into hydraulics were used not just to control the flows of water and waste, but also to transmit signals across the city. Sounds like a Renaissance version of a smart city to me. Perhaps more easily recognisable as Da Vinci, the Annunciation is his earliest known painting from 1473. But the same mind devised the mechanical knight, a humanoid automaton which is said to have been able to sit, to stand, to raise its arms, and to lift its visor. The entire robotic system was operated from afar by a series of pulleys and cables. Here the application is medicine rather than warfare, but this robotic system has brought minimally invasive surgery to millions worldwide and can also be operated from afar, but across digital networks rather than by string. I could, of course, have used more instantly recognisable paintings and sketches. Perhaps I should have done. But then that would have made the game too easy. And there are so many startling inventions, it's difficult to choose. I think we all have our favourites, but I find the humble ball bearing to be amongst the most simple, beautiful and profound. It's manifest that Da Vinci's extraordinary and diverse talents fed off each other. It's something he himself believed and wrote about. but for the rest of us mere mortals, is innovation and technology driven by science, or does art, in its broadest sense, play more of a part than we might imagine? I'll use the rest of the 2018 Turing lecture to explore this question. The Greek philosophers believed that mathematics could be used to describe and reason about phenomena in the real world, an idea rekindled during the Renaissance, not least by Da Vinci and his deep fascination with geometry. While science, from the Latin word scientia meaning knowledge, is a systematic enterprise for building and organising information, understanding and explanations about the material world. But mathematics and science do not in themselves drive innovation. Yes, they are essential tools to be used along the way, and scientific advances undoubtedly make developments of technology possible. But they're not sufficient. Nor, in my experience, does innovation and technology follow the scientific method to any great degree. What about engineering? Well, it's the application of scientific knowledge and mathematical methods to practical design, and certainly gets us a little closer to the march of technology. STEM programs encourage interest and uptake of these subjects, and it's imperative, of course, that we raise the level of skills, not just to make us more proficient consumers of digital information, but to create more producers, fueling advances in technology. But a recent study from the University of Michigan shows a profound link between early exposure to fine arts, craft, music and drama, and scientific ability. There are crossover skills, including observing, imaging and visualization, abstracting, pattern recognition and pattern invention, modelling and even manual dexterity. For example, one of the strongest predictors of success in scientific subjects among the under 18s is visual imaging ability, which is a skill best enhanced by learning to observe through drawing or model making. The same report found that Nobel Prize winners are about 20 times more likely than the average scientist to engage in painting, writing or performing arts. It also found that a significant majority of scientists and engineers would recommend arts and crafts education as a useful or even essential background for a scientific innovator. So there does seem to me to be something wrong with this. It is quite literally unwholesome. Creating compelling technology draws upon a far wider set of skills, and there are many other forces driving successful innovation. On the whole, they're not very scientific, as we will discover through the next 10 themes. Let's start with creativity, the process of turning ideas into original concepts and artifacts of value or of use. It's characterized by the ability to perceive the world in new ways, to find hidden patterns, to make connections between seemingly unrelated phenomena, and to generate solutions. We can think of it as the next step on from imagination. The age-old question with creativity has always been whether we're simply born with this gift or whether it can be nurtured and enhanced. Creativity may relate to the amount of large-scale connectivity between brain areas, and genes may play a role in the development of these pathways. The conjecture is that greater brain connectivity reduces inhibition of emotions and memory, and so more information reaches the level of consciousness. But it is at present unclear to what extent physiology is a determining factor. On the other hand, there's strong belief that the ingredients of creativity can be taught in the classroom and also in later life. Children are able to play and experiment with weird things without fear or shame. They're able to challenge, ask the silly questions, refuse the received wisdom, be rebellious, and enjoy playful leaps of imagination. These are all things that can be encouraged and facilitated. But preparing for creativity requires something more. It requires extra disciplinary interests and exploration. Reaching a level of skill in music, art, drama or sport contributes to a more creative approach in general. This may be because becoming proficient at something requires endeavour and builds confidence, which are both important forces in the creative process, whatever the target. We need to do more to understand and deliver this through schools and find a better balance between creating conformance and homogeneity and celebrating the talents of the sparky individual. Ken Robinson's influential TED Talk of 2006, in which he argued that education practices crush creative talents, remains the most watched TED Talk of all time. The creative process is often caricatured as flashes of imagination and spontaneous bursts of new ideas, but in reality, creativity reforms and reshapes the old to the new, using the full variety of information and experiences that we already possess. Developing an outward-looking perspective creates knowledge and interest in the world, its geographies, economics, politics, and societies, and builds around a context in which the creative mind can operate. So is it too late once we've left school? As we get older, we certainly become more fearful of social rejection and become more cautious and less creative. But I found a number of tricks over the years and interventions to be useful in releasing the creative brakes. The first is to concentrate on the human aspects of the problem space. Thinking about people, what drives them, and how they relate to technology, rather than the nuts and bolts of the invention itself, takes the creative process down a particular path that I've found to be more productive. Another exercise is to occasionally spend a few minutes engaged in rapid random thinking. Allow your mind to wander, but then require it to come up with an image every second. The images that flow might not seem connected, but they must be for your subconscious mind to take you on the journey. You might not remember the sequence, but some of the connectivities are brought a little further forward in the consciousness. A related technique is to disrupt a brainstorming activity by introducing a random object, and then insisting on finding a way to link it to the discussion. It sounds whimsical, but it does seem to work, perhaps forcing the brain to give up old patterns and search for new ones. That's often what has happened when an inventor makes a breakthrough. A key antecedent of creativity is motivation. Those who are intrinsically motivated tend to be more creative, and a desire to contribute to the lives of others or solve an imperative problem enhances the creative process. Computing and the internet came about entirely through necessity. When Charles Babbage began designing mechanical calculating machines in the 1820s, he was motivated to produce more accurate mathematical and astronomical tables. These tables were hand-calculated by people known as computers and contained many errors which resulted in financial loss, engineering mistakes, and even accidents. His machines were fully programmable, using punch cards, and included an output mechanism to print tables. The Analytical engine was first designed in London, and had it been completed, it would have been the first computer. The motivation for Colossus, designed and built by Tommy Flowers in London and assembled in Bletchley Park, was to crack the German Lorentz cipher. It did this successfully from 1944, and it's been estimated that the Second World War was shortened by 2 years as a result of Colossus, the first computer. Freddie Williams and Tom Kilburn turned a cathode ray tube into a random access memory, but needed a testbed to put it through its paces, which became the motivation for the Manchester Small-Scale Experimental Machine, or BABY, which in 1948 became the first computer. Meanwhile, Maurice Wilkes was motivated to provide a practical and reliable computation service to satisfy the burgeoning need of scientists in Cambridge to solve equations and analyse sequences of data. He built EDSAC, which ran its first program in 1949, and so became the first computer. The motivation for the internet was to remove clutter from Bob Taylor's office in the Pentagon. Bob was in charge of research programs at the government research agency ARPA. He had 3 different terminals in his office, connected to 3 different mainframes. Each mainframe had their own community of users, but they were not connected to each other. Bob wanted a single terminal and a single community, and the ARPANET project was born to devise a universal switching network. The motivation for the World Wide Web was to allow scientists at CERN to share experimental data amongst themselves and with colleagues worldwide. By the late 80s, millions of computers were now connected to the internet, but sharing information was still haphazard. The solution that Tim Berners-Lee came up with was to embrace hypertext links and to develop a universal protocol that would allow web servers and web browsers to talk to each other. Tim realized from the outset the enormous potential of his approach, but his manager at CERN took a little longer, as the handwritten note on Tim's original 1989 paper shows. Just a few years later, I led the team that developed a hugely successful internet application, VNC, which allows the screen of any device to be used from the screen of any other device. It was motivated by my laziness. I was Director of Research and Engineering at a lab in Cambridge, and Maurice Wilkes, of EDSAC fame, was a consultant. By now in his 80s, Maurice occasionally had trouble with his computer, which I used to help sort out. VNC was born in 1994 as a way of me seeing and interacting with his computer screen from the computer screen in my office without me having to get out of my chair. If you've ever had someone take over control of your computer screen to help fix a problem, it's likely to be a VNC, or a derivative of it, or an imitator of it. There are billions of copies of VNC, and it's become the most widely ported application of all time on more different kinds of computer and systems than any other device. It's on every kind of desktop, laptop, tablet and mobile phone you can think of. It's on games consoles, smartwatches, virtual and augmented reality systems. It can run within any browser and is integrated into set-top boxes, point-of-sale terminals, ATMs, medical instruments, domestic appliances and cars, to name just a few. And it's embedded directly in the silicon of many hundreds of millions of chips. Most of these devices did not exist when VNC was created, and VNC will be able to work on devices that do not yet exist. It's fully backwards and forwards compatible and fully interoperable between all kinds of device. What makes it even more amazing is that it's more complex than you might imagine. The software needs detailed knowledge of how to interact with the screen, keyboard and mouse for a given operating system and hardware configuration. There have been 50 variants of Windows alone between Windows 95 and Windows 10, and taking into account all the versions of Mac, Unix, phone operating systems and embedded operating systems that the software works on, the number of platforms runs into thousands. But it isn't just a standalone application running on a computer, like a calculator or PowerPoint or a chess-playing program. It interacts over a network with complementary software running at the other end. And writing distributed systems that are reliable and robust makes the already significant challenge of portability several orders of magnitude greater. It starts to get more complex still because the computer at the other end might be quite different. Not only is the operating system different, but the keyboard is different, the mouse is different, and the screen is of a different size and resolution, which means that the software must accommodate significant changes. There might not even be a mouse or keyboard at all, which requires even more radical adaptation. And the system must adapt to different kinds of networks, bandwidths, latencies, and reliabilities. But possibly the most challenging aspect of all is that there is a person in the loop, expecting an interactive real-time experience, which puts a profound constraint on the architecture and design of the system. I'll say a little more later on about the arts and crafts that have made such a complex system work on so many different platforms, and to be still going strong some 20 years later. It isn't just sufficient to have interesting ideas. You have to tell a story and capture the imagination if you want to make a difference. Nikola Tesla was one of the great inventors at the dawn of the electrical age, but he was also a consummate showman and a skillful fundraiser, entertaining audiences and crowds with spectacular shows of electrical and luminescent effects. Many of his inventions and ideas were ahead of their time, and he ended up in poverty. Altogether more successful in business, but no less a showman, Steve Jobs brought style and a huge sense of theatre to the launch of product after product. He knew how to build anticipation through enigmatic marketing, as well as designing stylish products with a must-have factor. And if you've already rewired society with the leading social media app, and you want to change the world again with virtual reality, you have to put on a fabulous show, which is exactly what Mark Zuckerberg did here. But Elon Musk is in a different league to all that have gone before. His remarkable technical accomplishments are at the service of a breathtaking vision about our next evolutionary steps on Earth and beyond. This was the first launch just 2 weeks ago of his Falcon Heavy rocket. It's a game changer. The payload is double that of any other operational rocket, and because the reusable booster rockets enable a radically lower cost to put an object into space.
And the Falcons have landed.
The booster rockets didn't have to land simultaneously, but they did, because like a magician, he has mastery over the props. And in the most eye-catching way possible, what did Elon Musk send off on a journey to Mars?
There's a starman waiting in the sky. He'd like to come and meet us, but he thinks he'd blow our minds. There's a starman waiting in the sky. He's told us not to blow it, 'cause he knows it's all worthwhile.
You can call it marketing, publicity, or communications, but the best at it are storytellers, pure and simple, and are practiced in their art form. Storytelling captures the imagination and galvanizes into action. It can create desire and turn technology push into customer pull at a stroke. So we've been creative, we've identified a need, and we have a story to tell. But there are other skills we must master for our innovations to succeed.
Say, what is the secret of great comedy?
I don't know. What is the secret of
Timing.
great
This recording was made at the Grand Opera House in Belfast in 1980. The other voice is comedy writer Richard Curtis. There's a saying in business that being early is as good as being wrong. There's another saying in business that being late is as good as being wrong. So timing is critical, but is it all just luck? Here's the Apple Newton from 1993. John Scully, Apple's CEO at the time, was the driving force behind this. He even coined the term Personal Digital Assistant, or PDA. The idea was to reinvent personal computing. They needed a low-power processor and found the Acorn RISC machine. And that's pretty much how ARM started, and it's the Newton's probable real legacy. As a device, it was probably too far ahead of its time in some ways, and willfully ignorant of industry developments in others. It suffered from feature creep, and the handwriting recognition was erratic, to say the least. When Jobs returned to Apple as CEO in 1997, he killed it off with these words: "I tried one and thought it was a piece of junk, so I threw it away. I didn't want a little scribble thing, I wanted something with a keyboard." But the real killer was that it wasn't connected to the network, so it couldn't even send an email or make a simple phone call. Here's something that was connected to the network and could do those things. I was responsible for AT&T's broadband phone project, and this was a mobile version that we developed, including all the software and the user interface design from about 1999. This is a photo of my hand holding the world's first fully functional, full-colour smartphone complete with touchscreen. Our system implemented full telephone functionality with speakerphone and echo consolation. We developed an application programming toolkit to make designing and implementing applications easy for the non-expert. We adopted a cloud architecture and the model of software as a service. We devised the concept of a curated set of applications and the notion of quality control and policies to ensure a compatible set of applications. We implemented applications for email, web browsing, making notes, storing contacts, and instant messaging. We had a library of music and a suite of games. And we designed an appealing and intuitive user interface. What's more, we deployed hundreds of this kind of device and demonstrated them widely to senior executives throughout the industry. But the timing was wrong. The world wasn't ready for a relatively expensive computer phone. We'd solved the technical challenges, and the creativity, inventiveness, and storytelling were a compelling prophecy. But the need did not yet exist. Social media had yet to take off, and we weren't yet addicted to email and the web in a way that we are now. These things have now become a near constant activity for us, requiring and demanding a sophisticated device permanently at our fingertips. But the genes survived and without doubt influenced others. Here's an image taken from Apple's marketing for the launch of the first iPhone in 2007. I'll let the pictures speak for themselves, I think. A degree of anticipation is a good thing. It's always interesting to think of a world where networks are 1,000 or 1,000,000 times faster, and there are similar leaps in memory capacity and processor speeds, and to then build prototypes and envisionments of systems that might inhabit such a future landscape. This has certainly been a productive line of inquiry throughout my career, and the phone has just been perhaps the most visually striking example we have anticipated. Just with comedy, timing is everything for successful innovation. You must have credible technology and genuine need. But more than that, market forces need to be aligned. There cannot be any regulatory or political barriers, and we must be culturally receptive. Some of these can be influenced, for example, with good storytelling, but ultimately, it's a matter of judging the moment. Here's a lovely twist on an old saying, which is the inspiration for this section. And here's an all too familiar scene of modern life, a couple busy on their phones not talking to each other. But it's nothing new. Here's a prediction of the future of wireless telegraphy from satirical magazine Punch. The caption reads, "These two figures are not communicating with one another. The lady is receiving an amatory message and the gentleman some racing results." It's illuminating to know our past, and so I hope you were listening earlier because here is a test. Which place can lay claim to the first computer? Hands up if you think London. Anyone? Yes, a few people think London. Hands up if you think Bletchley Park. Oh, a few more hands for Bletchley. Anyone think Manchester? Oh, quite a lot for Manchester. Good. Anyone think Cambridge? Ooh, not many for Cambridge. Of course, if you choose the definition correctly, I think they can all claim to be the first computer. But actually it's a trick question and you're all wrong. The answer is Rhodes, and the date is about 200 BC. 100 years or so later, this mechanism was lost in a shipwreck off the island of Antikythera on the edge of the Aegean Sea, and there it remained until it was rediscovered by fishermen in 1900. The Antikythera mechanism is an amazingly sophisticated astronomical calculator predicting the position of the moon and planets, lunar and solar eclipses and other events. It even has the concept of 365¼ days in the year. What makes this device all the more intriguing is that it is, as far as we know, unique. Recent X-rays have revealed a jaw-droppingly intricate system of gears, cogs and differentials. Technological artifacts approaching this complexity and workmanship did not appear again until Da Vinci's time. What's more, it was designed to be portable and used by a non-expert. There is even a 2,000-word engraved instruction manual. Modern replicas work beautifully with astonishing accuracy, and Apple engineer Andy Carroll has even built a working replica out of Lego. If Babbage's analytical engine was the first digital computer, then the Antikythera mechanism was the first analog computer. Yet, however incredible it seems to us now, what must it have seemed like at the time? There's no better example I can think of Arthur C. Clarke's third law, which states, any sufficiently advanced technology is indistinguishable from magic. There isn't much that Arthur C. Clarke and other science fiction writers have not mapped out for us, sometimes in considerable technical detail. It isn't just about flying saucers and aliens, but covers every conceivable branch of science, technology, and the environment. And just as important are the ethical, economic, and societal observations and predictions that science fiction makes. Edgar Allan Poe was one of the founders of science fiction. His 1848 essay Eureka predicts the Big Bang in some detail, and in so doing contains the first plausible answer to Olbers' paradox. Some 80 years later, George Lemaitre, a graduate student of St Edmund's College in Cambridge, where I'm a fellow, published the theory of an expanding universe and the hypothesis of a primeval atom, or cosmic egg, as he called it. He knew of Poe's essay. Edwin Hubble may not have known about Lemaitre's theory because it was published in French, and so the law and the corresponding constant that Lemaitre worked out 2 years earlier bears Hubble's name. But Poe himself knew of the work of this person, Erasmus Darwin, grandfather of Charles. In a 1791 poem entitled The Economy of Vegetation, Erasmus Darwin speculated not only on the Big Bang, but also on the Big Crunch. In the arts world, a retrospective is a deep dive in and around an artist or a writer's work, looking for influences and connections, and presenting surprising juxtapositions. A well-put-together exhibition takes you beyond their work and asks more profound, often philosophical questions, which serve to provide some greater insight. I believe we should take the same care and effort to curate our own inventive and technological heritage as a gallery would an artist. It can't be put any better than by Da Vinci himself. Having a good eye for detail is crucial in engineering and technology. I wonder how many of you spotted this mistake. Steve Jobs had a legendary eye for detail. He once phoned Bill Gates in the middle of the night to tell him about a spelling error in the documentation for Microsoft Word. In computing, it's tempting to disregard the edge and corner cases of an algorithm because they're rare and unlikely and hard work to program. But ignoring them often means the problem is not correctly characterized and the implementation prone to error. Ariane rocket 501 lasted only 40 seconds from launch in June 1996. The cause was guidance instability as a result of an arithmetic overflow in a corner case of the algorithms for the inertial systems. It's possible that better testing could have prevented this, but there is no substitute for observant design, correct by construction. The Millennium Bridge was fine on paper, and the vertical effects of crowds of people walking and running across it had been expensively modelled. But the horizontal effects were thought to be negligible and were not modelled. In practice, the natural cadence of people caused sideways oscillations, which in turn caused them to sway in step. The bridge was closed for 2 years until dampers could be retrofitted, which, with a little more circumspection at the design stage, could have been avoided. And the Vassar warship sank after sailing just a few hundred metres on its maiden voyage out of Stockholm Harbour in 1628. It was top-heavy, but worse was the asymmetric distribution of mass from port to starboard. Some workmen had used Swedish feet, which had 12 inches, and some had used Amsterdam feet, which had 11 inches. The ship listed to port at launch and soon rolled over completely. During building, no one noticed that the workmen's rulers were of different lengths. Learning how to observe carefully is an art that can be taught and a skill that can be acquired. A curious mind looks for detail, structure, and patterns, whether geometric, grammatical, or in combinations and sequences of effects. It spots the out of place and anticipates the unexpected. We've already heard that laziness was one of the motivations for VNC. Laziness, or idly doing nothing, is a rare commodity these days. We're immersed in a digital world, which draws us in and compels us to be constantly connected and active. We've become distracted by devices and are being conditioned to behave in a Pavlovian way. When do we think? When is our imagination allowed to breathe? Guy Claxon has written eloquently about the quick-thinking, results-oriented harebrain trying to solve problems under pressure, and the slower tortoise mind patiently absorbing confusion, ambiguity, paradox, and sleeping on it. Einstein slept a great deal, but also practiced micronapping, where he never drifted into sleep proper. He would sit in his armchair holding a spoon, in the knowledge that if he dozed off, he would wake up when he dropped it. Edison did something similar and claimed his mind was flooded with images when he was half awake. And while painting the Mona Lisa, Da Vinci was living off only 2 hours of sleep a day, with micronaps every couple of hours. There is an art to being idle. It requires discipline and determination. But the luxury of laziness and daydreaming allows us to make creative connections and to see things more clearly. That was the aria from Bach's Goldberg Variations, played by Glenn Gould in his historic debut recording of 1955. Both the music and the interpretation are simple, without ornamentation or affectation. It is in just 2 parts, without complex harmonies or chords, but it has a timeless, transcendental quality. The unartful inventor and engineer will tend toward adding things and creating complexity. They're prone to solve problems that don't exist and provide functionality that is not required. While an artist will strip away things and strive to shed light on a central, lasting essence. Returning for a moment to the VNC story, one of the main reasons that it has endured and become universal is that we chose simplicity as a guiding principle. First, we chose to deal in the simplest possible primitives. We read, transmit and write pixels from end to end without any knowledge of what they mean. Whilst it can be more efficient in terms of processor, memory and network bandwidth to deal in higher level primitives, such as draw the letter X in this particular font, size and colour at a particular place on the screen, it's less portable, involves more lines of code, and makes more shared assumptions across the network. Second, we designed an elegant protocol to transmit VNC data across the network. It included in the outset a simple mechanism to allow new types of message to be added at a later date in a backwards compatible way, without changing the fundamental protocol. For example, during the lifetime of VNC, industry standards for security have strengthened and compression algorithms have evolved. Incorporating these has not required changes to the protocol. And finally, the reference source code, which we published in 1998 and from which all versions flow, embodies the model of a platform-independent abstract computer with platform-specific implementations. It did this through the power and elegance of an object-oriented framework in both C++ and Java flavors. These were forward-looking choices at the time. In software, we often say that 99% of people use 1% of the functionality. Striving for simplicity creates a tension about what to leave out and what to keep in, and how one part of the software relates to another. This tension creates a deeper understanding. We have resisted adding functionality and complexity to VNC for 20 years, and it's possible to build a simple, compatible version now with fewer lines of code than it was then. Adaptation is an essential ingredient in the continuing success of technology businesses. Polaroid enjoyed a hugely successful period between 1940 and 1980 with their instant film cameras. The cameras were fairly cheap, but the film was where the money was and generated massive profits. Polaroid was a very inventive company and reinvested heavily in R&D. They spent hundreds of millions of dollars on Polavision, an instant movie film technology. Unfortunately, the movies only lasted 2.5 minutes, there was no sound, and the extremely slow film speed required very bright lights. By the time it came out, videotape was already gaining popularity and worked much better. Polavision was dead before it reached the shops, and the company has been bankrupt and reformed 3 times since. There's a similar story in Polaroid's arch-rival Kodak. They had an incredibly large and successful business selling still and movie cameras and the accompanying film stock and photographic papers. But in 1975, Steve Sassoon used the recently invented charge-coupled device to build the world's first digital imaging camera. It was slow and very low resolution, and his bosses at Kodak asked how long it would take for the technology to mature sufficiently to become practical. He used Moore's law, which says that the number of transistors on a chip doubles every 2 years, to predict somewhere between 12 and 15 years. His bosses were lukewarm because they couldn't see beyond film and print. But the company was awash with money, and the project continued on the proviso that it was not allowed to publicly talk about it or show his prototypes outside of Kodak. His prediction was remarkably accurate, and 14 years later, in 1989, he produced the first single-lens digital reflex camera with a 1.2 megapixel sensor, image compression, and digital memory cards. Kodak knew the camera would sell, but were worried that it would cannibalize the company's film and paper sales. The camera never saw the light of day. Other companies launched similar products, and Kodak later tried to enter the market, but by then it was too late. Kodak filed for bankruptcy in 2012. After much restructuring, parts of the company survive and are desperately trying to find a new purpose. This was launched at the Consumer Electronics Show in Las Vegas in January of this year. It's a Bitcoin miner that will retail for about $3,000. Hands up if you think this is a good idea. Oh, one? Interesting, I'm not sure given their track record. Anyway, organisations and enterprises do undoubtedly need to evolve. When AT&T restructured in 2002 and closed all but one of their research labs, the amazing projects from the Cambridge lab, like our broadband phone, came to an abrupt end. But from the ashes of this destruction rose 10 brand new startup companies. Most still exist and have been very successful. It's how VNC became a commercial entity. We set about financing the company in a novel way. We knew our many millions of users wanted the software to continue being developed and supported. And we knew they had a wish list which could inform our technology roadmap. So we designed some VNC branded merchandise and put a simple shopping cart on the front page of the website. Over the next 18 months, we sold tens of thousands of items and made hundreds of thousands of pounds profit. We suspected that not everyone wanted yet another t-shirt, so we also put a simple button on the front page of the website to make a donation. The hunch was correct, and we received several hundred thousands of pounds of what at the time we called free money. Ours was the first technology company I'm aware of to be founded with what was only later in 2006 to become known as crowdfunding. Adaptation isn't just about product innovation and R&D, it's equally about business model flexibility and seeing lateral opportunities. We talk now of the difference in attitudes between America and the UK towards the adoption and adaptation of technology. But as we saw earlier, there is nothing new, and Babbage understood this long before us. Despite the bleakness of Dawkins' take on Darwinian principles, The industrial era has benefited hugely from patronage and philanthropy. This is particularly true of the digital age, where in many cases the means to produce and deliver the applications and services that we intimately rely on are all apparently free. Over the last 25 years, the open source and free software movements have produced a wealth of tools and operating systems which are not only free to use, but are free to modify, adapt, and improve in a collaborative way. While some of these projects have benefited from significant resources from commercial companies, many have been the fruits of individual unpaid labour. Either way, it's a generous and philanthropic act, and for many contributors, it's seen as a technical means to a social end. These free tools have in turn enabled a plethora of free applications, many providing cloud-based functionality and storage. This has radically simplified the computing paradigm, and not only are there free services, but they are easier to use and so more inclusive. Over the same time frame, information has become free and available to a degree only previously imagined in science fiction. The Internet, the World Wide Web, Google and Wikipedia are all in effect free to the majority of the world. Some of this has happened alongside parallel commercial strategies, but we're all at liberty to ignore the advertising that embellishes the results of a Google search. There is more to this than simply making money, and many of the most successful innovators and technologists have a strong philanthropic streak and a vision and determination to tackle some of the most pressing societal and environmental problems of our time. As we draw to a close, I thought we might repeat the show of hands that we started with. Do you now think innovation and technology owe more to science or to art? Hands up if you think science. At least there's more hands up than earlier on. Hands up if you think art. Oh, a lot more hands. Very good. And so to Alan Turing, a founding father of computing and artificial intelligence. I thought I might finish with some highly personal reflections on this subject. We've recently seen dazzling and groundbreaking advances in machine learning, which have transformed speech recognition and computer vision systems to the point that they're almost becoming reliable, predictable, and useful. Perhaps the most eye-catching advance is AlphaGo, a system based on machine learning trained with extensive human and computer play. Last year, it beat the world #1 Go player. Since then, DeepMind have demonstrated AlphaGo Zero, a version without human data, trained only with play against itself, which was able to beat its ancestor, AlphaGo. This is without doubt a major milestone in the development of artificial intelligence. Another area where machine learning has a central role is autonomous vehicles. This has caught the public imagination, and there is enormous excitement, matched only by the vast amounts of investment and effort. Vehicles are at advanced stages of development and testing, and apparently they are coming to a street near you soon. But I, for one, am not holding my breath. This is the magic roundabout in Swindon, which has been happily conveying motorists since 1972. There are actually 7 roundabouts in one. You can get from A to B without going round the circle, and you can use different routes to get to the same exit. There are many different ways through the roundabout, and it looks chaotic, but actually it's very efficient because there is less fighting for space. I do not believe any autonomous vehicle under development would cope with this at all well. But it is far from unique. This is Meskel Square in Addis Ababa. There's no roundabout, no traffic lights, and no road markings, and there are hardly ever any accidents. And this is a typical street scene in Delhi. The human driver in these kinds of conditions does not behave autonomously. True, they're constantly mapping and remapping the boundaries of the street and sensing distances, velocities and trajectories of other vehicles and people. Some of this, without doubt, can be automated and even improved upon by machine. But the human driver is also making eye contact and reading body language, visual and audible signals, intentions and even emotions from other human road users in very nuanced and sophisticated ways. They're constantly exercising judgment and invoking intuition. This is completely beyond any computer system at present, and it's hard to see how an automated system of the kind being proposed will do anything other than either freeze or have an accident. In reality, an autonomous vehicle needs to solve the generalized artificial intelligence problem. For it to work, it needs to behave as a human being would, not only reacting to multiple sensors and inputs in real time, but drawing on knowledge and experience, patterns and connections that have been laid down, layer upon layer, connection upon connection, since birth, that allow the higher order analysis of the constantly changing scene and the appropriate human reaction to it. Why should we believe this if we cannot imagine this? I think there's a monumental gap between what's currently possible and the story that people are being told. Here's another thing that is, in my opinion, perhaps a little overhyped. The Internet of Things imagines a world where sensors, actuators, and the ability to communicate is embedded in virtually everything. The idea is to create a more direct integration of the physical world into computer-based systems, and to look for greater efficiency, accuracy, and automation. It promises a world at our service, making our lives simpler and easier. We're told that our fridges will automatically reorder our groceries, and our heating system will save energy by knowing that we will be late home. But for these kinds of things to work for us, they need to understand more of our intentions and motivations. In other words, the more interesting of the Internet of Things applications require generalized artificial intelligence too. So in autonomous vehicles and the Internet of Things, we have two perhaps overhyped technologies, but ones which might just have a symbiotic relationship. Here's the Delhi street scene again. Imagine the cab at the bottom is an autonomous vehicle. It has sophisticated systems for vision, radar, and so on. But if we have the Internet of Things, perhaps there are sensors and cameras at every lamppost that the cab systems can interrogate. There could be sensors marking the road, perhaps active paint or active cat's eyes, which the cab systems might also know about. And every vehicle could be transmitting useful information about itself, speed, intended route, and so on. Perhaps every person has a wearable of some kind that lets the cab systems know who is nearby, what their movement is, their heart rate, etc. The cab systems could have access to all this information, which could help it make better decisions and exercise better autonomous control. But here's the interesting bit. What if there is an Internet of Things service in the cloud? And what if everything flashing in the picture uploaded information in real time? And what if there was enormously powerful and deep automated reasoning there? And then what if aggregated information with path suggestions, alerts and warnings were relayed back to the cab systems? This might just be a way for a vehicle to become usefully autonomous. But I remain sceptical for the foreseeable future. To make strides towards generalized artificial intelligence, computers must begin to share an understanding of intent, motivation, and even empathy, which even a fully instrumented world cannot help with, because these things are internal to the mind. Through his work on computability, Turing showed us the theoretical equivalence of classes of computer, and so Babbage's analytical engine is exactly the same kind of computer as the one that plays Go so brilliantly. through his work on artificial intelligence, Turing gave us a way to decide if a machine could think. What will the breakthrough be, I wonder? I've got one last slide. The surgical robot is, of course, called Da Vinci. What else could it be? It's particularly good at prostate surgery, which is topical since the death rate from prostate cancer in the UK has recently overtaken that for breast cancer. Together with better and earlier detection rates, robots like this are the key to better outcomes for prostate cancer. And machine learning in systems like this is helping to identify tissue boundaries more accurately, making surgery even more precise and with fewer side effects. And as with many other kinds of medical instruments, VNC can be used to give technicians and clinicians remote access to the screens and controls. But like Da Vinci's mechanical knight, the robot is still at the service of the human operator and their art. Thank you for listening so attentively and being such a wonderful audience. Thank you.
Thank you, Andy. Well, ladies and gentlemen, once again, let's hear another round of applause for Andy and for Larissa. Larissa, would you like to join us up on the stage? Well, ladies and gentlemen, it's your turn now, so it's time to take some questions. So hopefully you've all been thinking of some along the way. My takeaway from today is that apparently I can micronap during the day.
Yes.
And without getting in trouble, it means I'm being more creative.
Very much so.
Brilliant. So I'm looking forward to that tomorrow at work, and there'll be no problems for any of my bosses who are in probably today. So we have a fantastic thing called a catch box with us today. We're going to throw it over to me. This is technology in a box. It's our microphone. It has accelerometers. I'm not an engineer, so I'm learning each day, but it has accelerometers, so you don't have to turn it on. When it throws to you, it'll turn on. When you throw it to someone else, it'll turn off. And if you put your hand up, we'll get somebody to throw it to you. So if you're not good at catching, warn the people around you. And if you're upstairs, lean right over as far. No, don't really. We'll probably leave you guys out of it for the moment. But we'll start here. Then I'm going to throw it out, and let's have some hands for the first question. Gentleman at the back of the sort of main front bit there. Oh, nearly.
Right. Can you hear me all right?
Yes.
One of the things, I'm an engineer who was hoping I might get a definition for art, because I haven't yet found one online. But the real thing I'm getting to is that you talk about imagination. Well, both art people, may I suggest that both art people and scientific people both use the same thing? Do we need to have this tribal difference between art and science?
It's certainly not intended to be a tribal discipline. It's intended to be a widening out of the thinking of what goes towards the creative process in technology. I think it's far more than just STEM subjects. I speak for STEM a great deal. I'm involved in a lot of STEM programs. I speak in lots of schools, but I observe that it's far more than that. And the things that go towards being creative and inventive are a much, much broader diet than that. It's certainly not one or the other, it's both.
Well, that's what
And that's what I'm hoping to say. If that hasn't come across, I'm sorry, but absolutely both.
No, that's not what I was suggesting. I was suggesting there's value in both.
Absolutely, I couldn't agree more.
Therefore, we shouldn't make a division between art and science.
No, the question was slightly provocative. It's not a scientific question. It was just a way of getting some hands up. And the answer is both. So I would actually have liked you to all put both of your hands up for both questions.
Excellent. Next question. Gentleman over there on the front row of the second bit. And if you can give us your name and also who you'd like to answer the question, that would probably be helpful as well. Brilliant.
Richard Melville, Cellularity. Yes, I find it bizarre that during the last talk you didn't mention once the name of Linus Torvalds. of course, Linus Torvalds, who created the Linux kernel, which is probably the most used operating system kernel in the world today. And also, of course, that kernel is responsible for the technology behind containerization, which is incredibly popular again in the world today. Not content with that, of course, he went on to produce the Git version control system, which again is probably the most used version control system in the world today. Listening to your talk, I did gather that you're a bit of an Apple fanboy, and I suspect that maybe that's the reason that you decided not to give the great Linus Torvalds his due.
Well, I'm sorry, it's not possible to name check everybody, but certainly in my section on generosity and philanthropy, that this whole idea of the open source and free software movement is absolutely about things like Linux and the whole GNU projects that have made those things available and made it possible for people to create the things that we all use for free. So if I didn't name check, I'm sorry, but absolutely included in that section.
There's a question over here. I think 1, 2, 3 rows just there. Oh, we're gonna do some throws. Next one forward. Go on forward, and then we'll go one back, and then we'll.
Thank you, Agile Awalia, Statoil. Firstly, I just want to say thank you, because that was one of the best lectures that I've been to here that I've had the pleasure to witness. So thank you so much for that. I think these to both speakers as well, because both sessions have given me a lot to think about, and that's what I like to get from these sessions. So once again, thank you. The last sort of messages you were giving, Andy, seem slightly to conflict with Larissa's. So I wondered if we... I'm being told at work that sometimes conflict can be good. So I just wanted to see if there was any sort of response to that, Larissa. Could you maybe... is the Internet of Things not everything that we hope it will be?
Yes. Well, I totally kind of understand the thing about like having a general kind of machine learning to take over all the place might be something very, very difficult for us to accomplish. But I do think that there's the potential of artificial intelligence to start working on small things. So for instance, we have precision agriculture today. So that problem that we had with wasting 500 trillion pounds like watering food we are going to throw away, precision agriculture is based on machine learning to help us to identify where to plant the seed, where to water. And also in medicine, I work with cancer detection for breast cancer. And today we know that we cannot give the same treatment for the same type of cancer, but in 2 different individuals. So we have to be very precise about this, and machine learning can help us to learn from different treatments and their outcome. So I feel like it's going to take a long time for us to have autonomous vehicles around, but I believe like the field is developing itself. If we looked in the past, like in the 60s when neural networks were in use, we couldn't do much with that because we didn't have the computer power. So it was quite difficult to use at that time, but the possibilities of today is so exciting. So I'm not like that skeptical about the advancements of machine learning, but I think it's going to take a huge time, not only for us to develop the technology, but also to embed like empathy and also curating our data much better, because we're going to rely on data to have all those autonomous systems. And as I said, if we have biased data, we have badly curated data, badly sampled data, that's never going to work. That's going to be very dangerous for humanity. So I think we have a long way to go. But yeah, I appreciate his view.
I'm a fan of machine learning. I think it's starting to do some fabulous things. I'm a fan of the Internet of Things. I think there are lots of point-to-point things that it's really going to help with. I think we mustn't oversell it, and it's not suddenly going to behave as if in the way that we want it to. It isn't intelligent to that degree, and I can't quite see when it will be. I think it's a very long way off for a fully automated, instrumented world to behave like we'd like it to.
If you could, gentleman behind Ed, and then we'll go to the front row over there, and then yourself down.
Thank you for saying it, and free software. I had the privilege of meeting Richard Stallman, another pioneer, on Friday. And obviously Torvalds worked with the 10% What are the ethical dimensions of knowledge? I'm trying to avoid the science and arts. Larissa has a clear message, is inspirational. And obviously we're going down this road of GDPR and the rights of the individual, but we're going to go away from the European court and jurisdiction that protects the individual. What's the role for the engineer and the IET and the BCS in that framework, ethically speaking?
It's come to me, so I know. Do you want to take the first stab at that?
I think it's really important that we know what our software is doing and why it's doing it and what the provenance of it is. And I think to be able to prove why a piece of software has done a certain thing is one of the tools we might use in creating an ethical framework of software and applications. That's the first thing I can think of. Larissa?
So especially like machine learning, so when we work with neural networks and deep learning, that's a kind of a black box. It's difficult for us to understand how the calculations are being performed inside. So it goes again like to the data, like to the provenance, and to the way that we process this, so we can have a more just outcome on the other side. It's like, so I truly believe that the way that we have to devote a lot of our time on the curation of the information, we're going to make decisions based on if that makes sense to you. So I feel like there's a very long way to go in terms of veracity of data, also semantics to understand the relevance of one data to another. So I feel like we are not there yet, and there's a lot of work for us to enable machine learning to continue being like neural networks, being a black box, but still produce good quality results in the end.
I think also the role of governments and legal frameworks is interesting because on one hand you'd like to have something like that, but on the other hand it sort of goes against the sort of freedom of software, freedom of information. So there is a tension there.
Indeed, like just to add on that, so like for instance we have in the UK, for instance, the right to be forgotten. And then we think about like, we want to use blockchain and all those things. So how personal data comes into play as we adopt those modern digital technology. So kind of ethical, like establishing an ethical framework and to preserve the privacy of citizens and individuals is going to be really, really necessary for us to enable all this exciting technology that is yet to come.
There was a gentleman in the middle at the back there, and then we'll throw it down over the front, so get ready in the middle there.
Hi, thank you both very much for such interesting lectures. In the second talk, you mentioned the alpha machine that could, the Go learning machine that could beat its predecessor simply by playing itself. At what point does that become very scary, where machines learn things simply for themselves, all on their own, and what will they do with that information?
It's something that people worry about, and far greater minds than me. So Martin Rees has started a Centre for Existential Risk in Cambridge. Stephen Hawking's worried about it. Elon Musk is worried about it. I'm rather more pragmatic, and I think that these things will not just take over. I think life is a little bit more incremental than that, and I think these systems will be a little bit more incremental. The worst thing that seems to be happening to me is that somebody's voice recognition system ordered some cat food for them recently because it heard the advert on the TV and that got fed into the voice recognition system and it bought some cat food. Well, I think I can live with that. Another bad thing that happens is the automatic trading systems kick in and you lose 1 or 2% on the stock markets, but people notice and intervene, and there are bigger forces at work than the automated trading. So I'm hopeful that we will see these things coming in enough time to do something about them and pull the plug, if you like, or re-engineer our systems. So I'm not worried about it overnight.
Can I ask a little supplementary? What happens to people like me who are just no good with computers? I mean, are we just going to get left behind and there's going to be a whole other kind of world going forward that are doing all of this?
No, I don't think so. I mean, if you If you think about the iPhone, let's take the iPhone example, the smartphone example, it's so intuitive. We were actually in California in 2007 when the iPhone was launched, and my 2-year-old son, we got one of the first one from the Apple store in Cupertino, and my 2-year-old son picked it up and started using it. And I think it's an example. It's an example of how things, I think, are more inclusive and able to be used by more people.
It's not made me feel any better, but anyway. We'll pass it down to the front and move on before I get really upset. Yeah, my 18 months better on my iPhone than I am, to be honest. Go on, let's go for this. Oh, great.
Hi, it's David Short. I was wondering if you think Metcalfe's law will overtake Moore's law as a predictor of future progress.
Oh, that's
supplementary, before you've even answered. Is there also who do you think, what organisations do you think will capture the power of that global hyper-connected network, and how will they use it?
That's a good question, isn't it? Well, let me start with Moore's law. Is that going to keep going, is the first question I would ask. It's been going at double the numbers of transistors every 2 years. Actually, that exponent's changed slightly, but it's been pretty much that for 60 years. There will come a point when we can't make the features on chips any smaller, and there will come a point where the numbers of electrons involved in a 1 and a 0 is small, 50 or so electrons, and then it becomes, we're into quantum effects. So that might be a hard limit on Moore's law. And I've now forgotten the question. Oh, Metcalfe's law and networks.
Will Metcalfe's law overtake Moore's law as a predictor of progress, as networks double and double again?
Yes, I think it probably will, actually. I think the interconnectivity and the amounts of data that are stored and searched and indexed and exchanged constantly is the number that's increasing exponentially and will continue to.
We have time for one more question. There's a lady over there, about 4 in, so there's going to be a lot of throwing. Excellent. And this is our last question, ladies and gentlemen, so it's probably going to be 5, isn't it?
Yeah. I just wondered, has any research been done on how all of this is impacting mental health?
It's a very good question.
Well, I'm very sane because I can't get my iPhone to work, so I'm doing all right.
The short answer is no. It's not an area that I've been involved in, no.
Any thoughts how it's affecting mental health?
Not much on that, but like as of today, as I was giving example of the Internet of Skills, like there are a lot of people like working on having technology being brought to people who can benefit from this, so like that can help on that particular aspect, but not like on the effect of this technology in the negative side. So I don't have much experience on that, but I know that people are doing work on developing catering technology to serve, to improve like mental health and help somebody else's like well-being. So yeah, not much.
Well, ladies and gentlemen, I'm afraid that's all we have got time for. So ladies and gentlemen, can we please put our hands together for our 2 amazing speakers tonight, Andrew and Larissa. Thank you very much. Thank you. Brilliant. So, ladies and gentlemen, it's now time, but we have got a drinks reception out there today where you can see some really great technology showcases and have a chance to chat to people, and actually go around and discuss things with people out there. So make sure you have a little walk around out there. Also, while you're out there, there are a few leaflets for the Turing Trust. And this is a really, really important thing to just to talk about. It was founded in 2009 by Alan Turing's closest family. And it was in honour of his remarkable legacy. And its mission is to promote education and training through the use of information technology in schools right across Africa. In the last 9 years, the Trust improved access to education in 114 community-based schools and they've sent 4,000 computers to Malawi, Ghana, Liberia, Kenya, and through a computer reuse scheme. So if you have got any access to computers, to old computers, to getting involved in the reuse side of things, please pick up a leaflet and get involved, because it's a really, really important charity. Ladies and gentlemen, thank you for coming tonight. I hope you've enjoyed it, and we'll see you at the next talk. Cheers.